Good morning, folks. I'm Dan. Had a viewer ask if I would share the wiring for the PIDs that I use on my lubricizers in the shop, in the reloading room. And I've been hesitant to do that just because the safety police out there are going to say this is wrong and that's wrong and I should have wired this way and I should have done that. So the disclaimer is this is the way that I've wired these. It's not necessarily the way you want to wire them. You know, do your own research. Find out if this is really going to work for you or if it's not. And you proceed at your own risk. You know, I take no responsibility for anything I post here that you might decide to use. So that's the normal little disclaimer, and we can move on now because we're all responsible adults, hopefully. Otherwise, we probably shouldn't be playing with this stuff. So, playing with a little bit of new camera gear today. So I thought this was a good opportunity to try it out and see what we've come up with. So anyway, let's get right after it. So this is one of my lubricizers. This is an RCBS, and it's set up on the risers that I normally build. This way I can use, with my bench height that I use in the reloading room, why I can use these either standing or sitting on a stool. So it works really well for me. I mount most of my equipment on bases pretty much like this. You know, if they're lubricizers, single stage presses, things like that, I mount pretty much all of them here. And I've got a couple that I set permanently in place, and then I've got some interchangeable bases that I can quickly put these on and off if I need to. So anyway, shop built base, a little tray here to mount an Acro Mills bin on. I've welded these on out of angle iron at different times. This was an add-on afterwards, so I can put a standard little bin, Acro Mills bin like Dylan produces, and now everybody builds them, but that's the way I mount them. So I've got storage for bullets, lubricizer on top. This is the way I mount the PIDs on most of them. And another advantage of doing a base like this is it gives me some extra real estate so I can mount things like PIDs and brackets to mount bins and solid state relays and that kind of thing if I need them. So what I do is I take just a standard, and I normally will use a deep box. It gives a little more room, but a standard 4-gang outlet box with a solid plate on the side that I can mount them on. Inexpensive PID controllers, a on-off switch, and there's some improvements that could be made to the wiring of these, but this is the way I do mine. And at the end, I've got a drawing of this that I'll put up, and so you can take a better look at it. Solid state relay. I use a board in the back, just a terminal block, so that I can mount my power coming in and then take power off of there. From there, I've got a solid state relay on the back. I use a Heatsink here. I don't know that it's really necessary, but they're so inexpensive that I set them all up this way. And then my Thermocouple comes out and mounts in here. So what I've done is we've got power coming in, goes to the terminal block, 3 legs. One of them's a ground, of course. Out of the other side, we ground our ground on that terminal to our equipment. And then we take, let's see if I can actually remember and see how this goes through. One leg comes off, goes to one side of our switch to provide power there. The other terminal, or the other leg, comes back out of there, goes into the solid state relay, and in the drawing at the end, I'll show you all of the wiring for it and how it's connected on this particular PID. So anything I overlook when we just run through this very quickly, why it'll be explained there. And like I say, make sure you investigate, make sure that's the proper way to do it, because there's some improvements that can be made to that. Well, another leg comes off of our power switch, goes to one side of our heater. Now these heated bases, the standard ones for these small ones are just a 3/4 inch thick piece of aluminum. 4 inches by 4 inches is usually what I do them. I drill them for the cartridge heaters, and then I use a thermal paste in there to help transfer heat and to seal them a little bit, and then just tidy up the wiring so it looks nice. Power comes to one side of the PID, other side comes out and goes to the switch. Other side of the switch powers one leg of the heater, and the other side of the terminal block. The relay wiring is our one leg comes out, goes to our cartridge heater. The other leg comes out, goes to our solid state relay, and that's where another leg comes from inside on the PID to this side of the solid state relay. That is the main 110 circuit. The control circuit is terminals 3 and 4, and they're positive and negative. Two lines come out of there. one on each leg. One goes to the input side positive, one goes to the input side negative on the solid state relay. And that's our inputs to power. And the other wiring is for the thermocouple. It's on the back side. It's terminals 7 and 8 on this particular PID. Comes out, runs up, and I drilled the back of the base of the lubricizer itself and threaded it to accept our solid state, or to accept our thermocouple there. And that's pretty much an overview of the way I set them up. So right, wrong, or otherwise, that's the way I set them up. Use that information at your own risk. Use some common sense, and hopefully somebody can find this useful. And if you do and haven't already, I'd appreciate it if you hit that subscribe button. If you hit the bell notification, you will know when I put out a new video. And comments or suggestions, leave them in the comment section for me below. Don't bother to troll this one. We know about the wiring police. And as always, guys, thanks for taking the time to watch. Now, when I've got this equipment mounted in the reloading room, none of it is left plugged into the wall. There are some things that are on a power strip that's appropriate for whatever the situation is, but I have enough of these electrical attachments going on in the reloading room that I don't leave any of them plugged into power except when I'm actually utilizing them, or if I'm right there and present. I just feel there's too much potential for things to go wrong anyway, and unless I'm right there, why I don't leave them unattended. So when I'm done for the day, or when I'm done with that session in the reloading room, why everything that I've used, such as these PID controllers and the lubricizers, why they all get unplugged from power, so I don't leave anything plugged in and unattended. There's potential to where I should have guarding on things like the back of these over the solid state relays where those connections are exposed to mains. The way these mount in my reloading room, if you've watched a couple of my reloading room tours earlier on, why I've got for my lubricizers and my sizing equipment, things like that, why they're mounted on a very narrow bench. So it's basically appropriate for the space that I'm taking up with this equipment, and the backs of them are very close to the walls. So unless you're really stupid and stick your hand down there or something like that, why the potential for things to go wrong are, I consider, not a factor at all, although it would be appropriate to have some sort of a shielding over those terminals. So anyway, it's back to the same thing of personal responsibility, and utilize this information at your own risk.